In this video, we're going to continue on with our discussion of light mapping by moving on to the bake panel within our light mapping window. Now, this is where you control all of the settings for your actual light mapping setup, yeah?
Right. This is where all the magic happens.
Okay.
So let's start off by getting that window open. So we're going to go into Window, we're going to open up our light mapping panel. And in our last video, we were talking about the object panel. Now it's time to talk about the bake panel. Now, there's a whole bunch of settings in here, and we're going to get to them in a little bit. The first thing I want to do, though, is optimize some of these settings for doing some really fast test renders.
Okay.
By default, with the exception of our skylight, these are all set to what you would expect when you first came in.
Mm-hmm.
Now, these renders can take a bit. I think this particular render took us about 2-3 minutes, and I don't want to do that for every test tweak that we do with these settings.
Right.
So we're going to go through here, and we're going to dial some stuff down real quick. What we're going to do is we're going to start off with our quality tab. I'm going to just dump it down to low. I will come back and explain what these are doing in a little bit. I'm also going to take our final gather rays. I'm going to dial it down to 1. I'm going to take our contrast threshold, dial it down to 0. I'm going to turn off ambient occlusion and leave everything else set fairly low. I'm also, for the moment, going to turn off our skylight color. This will be set to default as well. Now, the last thing I want to do is take this resolution and dial it down from 50 to 5.
Mm-hmm.
Now, what this is doing, I do want to explain it here because I'm not going to come back to it at all. What this is doing is it's determining how many textuals per world unit to use for our light map.
All right, what does that mean?
What it means is if we have an object in our scene that is 1 meter by 1 meter, it's going to use our resolution and multiply that to figure out how many pixels of the light map to use to cover that texture.
So 1 meter by 1 meter would get how many pixels?
In this case, with a resolution of 5 pixels.
Okay.
So
now would that be 5 by 5 for a total of 25?
It would, for a total of 25 pixels.
Okay.
So 5 pixels across, 5 pixels up and down.
Okay.
So an object like this one, where it is defaulted at 10 meters by 10 meters
Mm-hmm.
with a resolution of 5, means that this overall texture would use 50 pixels by 50 pixels inside of our light map. With our last bake, we were using 1024 by 1024. This particular scene with a resolution of 5 will render at about, well, it will render a map of 128 by 128 pixels.
Because that's what it can fit it down into.
Right, which is 1/16 of this size.
Gotcha.
So you would expect at least, 1/16 of the time to render it.
So what the system is going to do is use that texels per world based on the size of your scene to figure out the size of the map that it can possibly use.
Right. And
But it looks like it's going to be in a power of 2, and it's going to be square however you go. So it'll be 128 or
Right.
256 or 512 and so on.
And if you remember earlier when we were in the last video when we were talking about the object, we have scale and light map.
Mm-hmm.
This allows us to scale an object in conjunction with our resolution to give it more space
Okay.
inside of that. So these all play together to determine how much actual pixels.
Kind of like a dominance factor. If you want one object to be more important and receive a little more of your resolution, you can set the scale in light map, and Unity will take that into account.
Exactly. So basically what to take away from this, these settings are preview settings. They're
Mm-hmm.
for generating very quick tests to see what your light is doing and your settings are doing in your scene.
Sure.
Now, with that being said, we are creating games here. So we want our renders to be fast, but because this is happening before we play the game, we can take our settings and go as crazy as we want, as long as you're willing to give up your computer to calculate these light maps before you play the game. Now the trick is, while dialing in these settings, you don't want your resolutions to be at final res. You want to create them down lower, get your light settings all dialed in, and once that's all said and done, you know your light's the way you want it, then take your resolutions and bump them up to the big size.
Right. Now that said, as you go from a really low res preview state to a high res, don't be surprised if certain artifacts suddenly appear that just weren't visible at the low res and require a little bit of further tweaking. That can happen. But generally, a low-resolution map is a great way to get an approximation of where you're going so that you don't spend a lot of time doing high-resolution bake after high-resolution bake over and over again.
Right. Right now, this is one of the high-resolution bakes. You can see where the light splashes. We've got these nice, smooth gradient transitions from light to shadow. our shadows on the ground are nice and smooth. We've got some nice glow from our illuminated object. This is what you get with some of the higher resolution settings. You
Gotcha.
can tweak this and make this look even better if you wanted to.
Mm-hmm.
Now, the moment I hit bake, though, we're using super, super low resolution stuff. So if I hit bake, our render is going to go really fast. We're done.
Ooh, but it looks terrible.
Yeah, we've got splotches all over the place.
Mm-hmm.
But it's enough to give us an idea of what's going on in our scene. We can see we've got some lighter areas here. We can see we've got some glow going on here. We've got some bounce light going in here and here. So this is a good way to quickly preview what's going on.
Okay.
So with that being said, let's get into some of these settings. Now, the first setting that I want to get into is going to be this mode. Now, what mode does is allows you to choose between single light maps and dual light maps. Now, in some of our previous videos, we're discussing where the different rendering models that you use inside of Unity will dictate whether or not they're using the far light map or the near light map.
Mm-hmm.
Deferred lighting, which is what we're using right now, uses both our near map and our far map for calculation.
Well, assuming that they haven't actually seen those, like any of those other videos you mentioned, why would you have two separate light maps?
Well, our far map is going to be a lower resolution map.
Mm-hmm.
Well, it's the same resolution as our near, but it's more concentrated, so it's spread out over a larger area of our scene.
Okay.
So you would use this in the distance, and it's going to hold all of the lighting information that our light maps have calculated. It holds all the bounce light, all the indirect light, all the light from self-illuminated objects, and it is the only means of lighting in distant objects when you're using the deferred lighting or vertex lighting or forward lighting.
So any of the rendering paths.
Right. Now, the near map only contains the bounce lighting information, self-illuminated information, and it's blended with real-time lighting close to the camera.
Okay, so it doesn't actually, the near map does not include the direct lighting itself. It's only going to include those bounce lights and things like the self-illumination, like the glow we have over there on the green ball, so that those can be combined with the real-time lighting in your scene so that it looks like your real-time lighting is also handling bounce light.
Right. Because this is very calculation intensive, we can't do it in real time. So we
Right.
do it ahead of time, and we blend it with real-time lighting to give an approximation of what bounce light would be doing.
Which comes back to why the near map couldn't hold all of your actual direct lighting, because you'd have twice the lighting. You'd have your real-time lighting, and then you'd have a map of your direct lighting on top of it. That's why your near map only holds your bounce light, just so that can be combined with the real-time light when you're close to an object.
Right, and that blending is controlled by our shadow distance. So we can blend in. So if you watch the shadow on the yellow box, this is right now, based on this distance, where that threshold is happening.
Mm-hmm.
So if I dial this in too close, we've lost lighting information from our real-time lighting, and we're only using the far map to calculate, which is why we're not seeing any real-time shadows.
Right, because that that real-time light has been pulled back in.
Right, but as you can see, we have our regular light information, we have indirect bounce light coming in, we've got self-illuminated
Mhm.
light. This information is all being held in that far map. So if we dial this all the way in, it looks terrible, but that's our low-res settings.
Right, that's what we'd see from far off.
But all of this is being pre-calculated. I could dial this all the way into 0, and I could grab our lights here, and I can turn them off. And other than the white box, which is only being lit with real-time lighting,
Right, because it's a dynamic object.
correct, everything looks the same.
Mm-hmm.
That's what we get with our far map. Now, as I dial this out,
Make
and
sure
I
you turn
push
your lights back on.
well, I want to
Oh, not
leave it
yet.
off.
Okay.
Right. So if I push this back, we can see this threshold being transitioned from our near map to our far map.
Mhm.
You only get this with deferred lighting, which is a pro-only feature.
Right, so if you're playing with this inside of the standard version of Unity and you're not seeing these same results, or you can't access these results, it's because what we're really showing at the moment is a pro-only feature.
Right. So as I dial this back out, we can see now we've lost the simulated light that's coming from our spotlights.
Right.
all we have is our indirect bounce light and our self-illumination light.
Right. The direct lighting in our scene would now come from our actual lights, which currently are turned off.
Right. So the moment I turn our lights back on, now remember, right here, all this is being supplied from our near map.
Mm-hmm.
So the moment I come back to our lights and turn them back on, activate children, we now have our real-time lighting, we get our real-time shadow back, and it's blended in with that indirect lighting information that
Very
we
nice.
had. So this is a good way of optimizing where our real-time lighting is going to fade in and out. And the closer you pull this, the less information that has to be calculated real-time. Good optimization trick. So I'm going to push this back out to, well, let's go with 25 just for now. That 2532, that's way out there.
And because our scenes are on, 10 by 10, we're pretty much only going to be looking at the near map.
Right. And our real-time map, our lighting. So that's all combined.
Mm-hmm.
So now the next part of this is we can toggle between single light map and dual light map. You can see if we're using our single, we've now gotten rid of that near information. We're just using the far map.
Right. Single light map is just going to be the far map only. Dual light maps will be both. Now, if we set this to dual and we're using anything other than the deferred rendering path, what happens?
Well, this has two functions. It controls whether or not deferred is going to use just the far map or both the far and near, but it also dictates whether or not it's going to render out both maps.
Okay.
So if you've got it selected to dual light maps, which you can do in Vertex and forward rendering, it will render both maps. It just won't use the near map information.
Right. And if you're using Unity Standard, you can't use your near map anyway.
Right.
So just keep that in mind.
So this is two purposes. It dictates whether or not it's going to render out both near and far maps, and dictate whether or not deferred rendering path will use both maps.
Okay.
Now, the quality setting has two settings as well. It has a high setting and a low setting.
It's like the shifter on pole position.
Yeah. Or, that little toy car, motorized car you had as a kid.
Sure.
It had high and low.
Oh, yeah.
So, now, these are predefined settings that Unity has gone ahead and given you to simplify some of the setting choices. We've got high, and as you can see here, it adjusts our final gather raise to 1,000, and it adjusts our contrast threshold a little bit. So if I go to low, it jumps us down to 200, but bumps up our contrast threshold to kind of smooth out the fact that we have less final gather raise. Now, this isn't the only thing it does. The light mapping system that Unity is using is built off of the Beast engine. There are tons and tons of settings that are hidden behind the scenes that you can't really see.
Okay.
This quality setting is adjusting some of those settings as well. It's adjusting some of the final gather point calculation settings. It's adjusting some of the anti-aliasing settings, but you can't see that because it's hidden away.
All right.
There are ways that you can get access to these settings, and it's beyond the scope of these videos, but just know that there is a file that you can create that is an XML based file that gives you setting or access to all those Beast settings, so you can tweak those much more than what is available inside of this light mapping panel.
Right, but demonstrating that XML file is a little bit beyond the scope of our discussion.
Right. So just know that this is just a subset of all the possible settings.
Right, and it's not just affecting sliders.
Exactly. Now, let's go ahead and reset some of this back down to our preview.
Our low-end preview settings.
Right. So with that, that'll cover quality. Let's move on to bounces. Now, bounces, if I dial this down to 0, it does a funny thing. It hides all of the other settings below it.
Right, and this is probably a lot closer to what you're going to see if you're using Unity Standard.
Right. If you don't have Pro and you're using Standard, this is what you're going to see. Now, the only difference between the way this looks and the way yours looks is this bounce drop down is going to be grayed out on your version.
Okay.
So you can't change this. So you can't go, oh, all I need to get those settings is, bump up my bounce count and I'll have them. You can't do that. You can't change it.
Okay.
Now, with bounces of 0, we're not going to calculate any of this indirect lighting. Matter of fact, if I go ahead and hit bake real quick, you can see we've lost the bounce light from our illumination. We've lost all the bounce light and indirect light in our scene altogether. It's not being calculated anymore. So what bounces does is determine how many times the rays of light are going to bounce off of an object and continue while calculating our lights. So with 1, we get some light bouncing around. We can bump this up to 3. I'm going to skip right over 2 because I'm not going to do 2 or 4.
All right.
I've got something against even numbers today.
All right, no problem.
So, as you can see, we've got even more light in the scene, and stuff is bouncing around a lot more.
Oh, yeah, it actually became more apparent that we've got some red light bouncing onto the wall next to our red ball, too.
Right over here, the green just lit up all over the place.
Mm-hmm.
Now, this is a performance consideration. You get a whole lot more light bouncing around in your scene, but at a cost of performance. Right now,
when you say a cost of performance, it is important to keep in mind that this is pre-baked.
It is.
And so you're not necessarily talking game performance.
No, we're talking render performance.
Right, how long you want this render to take. Now, if you're done with everything and you're ready for to create that final map that you can never worry about again, then yeah, this could take a long time, but you'd be okay with that.
Right.
But when we say that this will cause performance issues, I don't want you to be thinking in your head, oh, it's going to slow my game down. No. The whole purpose here is to pre-bake your lighting so that you can get a beautiful result that will play back as an image and therefore much faster.
Right. But what I meant by performance isn't your game time performance. It is how long you want to give up your computer to bake these maps out.
Right.
It is completely possible, and I've done it, where some of our light maps for some of our demo levels have exceeded 12 to 14 hours to bake out.
Right, and while you will read on places online that you can still work and use your computer while that happens, try it.
Yeah.
You'll find that your computer's probably quite busy at the moment.
Yeah, Super Wampidine Core 7 quad core still brought to its knees for 14 hours.
Yeah.
Yeah, I went and read a book. The whole book.
Yes.
So.
Okay, so moving on.
All right, so for most purposes, you're probably going to be able to get away with 1 bounce.
Mm-hmm.
If you need more, go ahead, feel free to do it. Just realize your bakes are going to take a lot longer. Next setting, skylight color. Now, this and skylight intensity play off of each other. So skylight color is going to always be whatever you set inside of this color swatch. But it's only going to work if your intensity is something other than 0.
Okay.
If you've got it at 0, you get no skylight color.
Just like intensity on an actual light, the skylight intensity is a multiplier. If it's set to 0, you're multiplying by 0 and nullifying the color.
Right. Now,
what is skylight color?
Skylight color is going to be the color that it's going to simulate or filling your scene with. So,
Sure.
like you walk outside on a bright blue, clear day,
Mm-hmm.
there's a blue tint or cast to everything.
Kind of like an ambient light.
Right.
So it's the diffuse air, the atmosphere, literally bringing light to you. Even though the sun may be coming directly in from your left, you're still going to see some light on the right-hand side of you as well.
Right.
On the left-hand side of you, excuse me.
In other words, your sky acts almost like an entire light source in
It's a
itself.
diffuser.
It's a very low intensity light, and that's what we're simulating here. We pick our color that we want that diffuse light to be, and then we give it an intensity.
Right.
And just like the sky outside, it's a very subtle effect.
Mm-hmm.
You do not want to go crazy with these numbers. I will go crazy with it just to prove a point.
0 to 1 is probably the biggest range you want to try to stay in. 3 is probably always going to blow something up.
All right, so let's see what happens. Let's go ahead and jump it up to 3. Now,
And
Yeah.
time to crawl underneath a lead parasol.
yeah, that's a little bit much. Get the SPF 50,000 out. It's going to be a rough day.
Actually, that's just duck and cover and wait for the fallout.
So let's get this back into something a little bit more useful. Let's try something like 0.15.
Okay.
Now we do another real quick bake, and we start to get a little bit of cool coloring.
Well, it's pretty subtle. Can you set it back to 0 and click bake one more time so they can see the shift down to nothing?
Sure, I can.
So watch very closely when he hits bake, and you'll see things darken up.
Right. It's very, very subtle, but that's all you need with this.
Mm-hmm.
You don't want to go heavy-handed.
And if you have a really intense outdoor scene, you might want to crank it up a little higher. It's all going to be situationally dependent.
Right. I've used settings up to about 4 or 5 in particular ones. Mostly, snow scenes.
Mm-hmm.
So you get a really bright day.
Okay.
So high noon or something. But again, it's all based on what you're trying to achieve.
Right.
So I dial this down a little bit more just because I want to be able to see some of the bounce light being thrown around a little bit easier.
Now this leads us to bounce boost and bounce intensity.
Right, now these two also play off of each other. Bounce boost is going to be a modifier to the light. It's not a multiplier, but it does increase the intensity of the light. It's almost gives the feel that the bounce light is reaching further into the scene, imparting a little bit more light.
Okay.
Now this, from the range of 0 to 4, is still a very subtle effect. So if I dial this down to 0 and I do a bake, it's going to darken up a little bit. Not a whole lot, but just a little bit. Now if I take this all the way to 4 and bake it out again, it's going to brighten up the scene, but just a little bit. It doesn't blow anything out.
Right. Well, I mean, it brightened things up quite a bit, but our bounces themselves, like, we're not seeing significantly more red light on the wall or significantly more green light coming out of our glowing object.
Right. It's just increasing the intensity of the light by a little bit. It's not causing the light to bounce around in the scene more.
Okay.
That's controlled by our bounces. If we want more bounces, we need to up the bounce count.
All right.
Now, I'm going to go ahead and dial this back down to 1. I'm going to show you what bounce intensity does. Bounce intensity is more heavy-handed. This is a true multiplier. So if I take this and I dial it down to 0 and hit bake.
Well, that should get rid of your bounces altogether because you're multiplying them by 0.
Yep. And that's exactly what it does.
Gotcha.
So it kills all of our indirect lighting. Now, conversely, I can dial this all the way up to 5. Because this is a multiplier, this means that it's going to make the lights 5 times as bright.
Right, and once again, we get to nuclear levels.
Right, and we've blown stuff out. Now,
burning shadows on the walls, that kind of thing.
Now, basically, bounce boost is supposed to, the definition is supposed to increase the amount of bounce light without blowing out the scene too quickly. That's what its job's to do. Bounce intensity is if you just can't get the effect that you need from bounce boost, you need to bump up the intensity of the light across the board, use the bounce intensity.
Right.
Just know that you can very easily blow out your whole scene if you're not careful with that.
So let's pull that back down to something a little more reasonable.
Yeah, back to 1. So, well, actually, I can show some numbers where it could possibly come in handy. Let's say about 1.25. So it does bring up the intensity, and it's not blowing anything out.
Well, you have to kind of compare it against 1, because seeing it go from nuclear levels to that, it's a little hard to tell.
Okay, so we'll drop it back down to 1.
And we see things darken back up.
Yep. And you can also use it as a darkening factor. So you can bring it to a number less than 1, but not quite 0. And this will darken your image down even more.
Kind of like a light damper.
So, but, you know, at these numbers, the effect is subtle, but once you start pushing beyond 2, things get out of hand really quickly. All right, now, rays. Final gather rays are the number of rays that are going to be spawned at every final gather point in your scene. The more rays you have, the more accurate your lighting map is going to be. Conversely, the more rays you have, the more calculations it has to do, so the longer times you're going to be spending rendering.
Sure, if you consider each ray to be kind of like a laser beam that is fired into your scene, that is going to bounce off of your objects to figure out where your incident lighting is going to go, this is the number of those lasers. This is the number of those beams that are actually fired out into your scene. The more beams you have, naturally, the more calculations need to take place. So putting a lot of final gather rays in will obviously slow your bake down.
Right. What I'm going to do is I'm going to dial down our skylight and get it completely out of our scene.
Okay.
So we can see the splotches a little bit easier. Now what I'm going to do is go from here, which is just a single final gather ray per point. And I'm going to take this, I'm going to bring it up to just 10.
Okay. And watch very closely when you hit
Watch the
bake.
walls specifically. So it's starting to smooth out, not a whole lot yet. So if I dial this up to 100, bake again.
It's taking a little longer each time, but now it's already a lot smoother than it was a moment ago.
Right, and this is at 100. This isn't even with 1,000 that the high quality comes in. But the more rays you have, the smoother your results are going to be. You can still see some of the splotchiness into the shadows.
Yes, you can.
So they are there. And this is just one of the numbers that you can use to help compensate and get that splotchiness out. This is going to be scene dependent. So depending on what you're baking out, your numbers could vary from what we have here.
Right, and it's also dependent on what you're looking at. If you were building like a grungy level, and you had a very noisy texture that had paint chipping and cracks in the walls and dirt and crevices and cracks and crannies, and it was a very noisy kind of rich texture,
you wouldn't notice.
You might not notice this kind of dirtiness in your light map, and it might be just fine.
So it's just adjust as needed.
But on the flip side, if you needed purely white walls or walls of a pure bright color, then you'd want to push those out as far as you possibly could.
Yeah, if you had nice, smooth white walls like this, you'd go fire the painter.
Exactly. Obviously, that wouldn't work for you.
So now, contrast threshold is a threshold that the engine uses to determine whether or not it's going to spawn off more final gather points.
Okay.
What it's doing is it's looking at what the lighting is doing across the surface and determining whether or not the changes is greater than this threshold and whether or not it has to calculate more.
Try to fill in holes, so to speak.
So it will go, oh, well, you've got quite a gradient here. I need to, throw in some more final gather points, hence more final gather rays to do the calculation. So as we dial this number up, what it's going to do is it's going to try to smooth out this result. Now, if you don't have enough rays and you're trying to smooth out with threshold, you're going to get smoother results, but you're going to lose detail in your light map.
Okay.
So things will smooth out, but you might not.
At the cost of fine details.
Right. So if I don't bring this up to, say, 0.5, which is its max, we get really, really nice stuff. But notice, it's smoothed out so much so that we've lost our bounce lighting.
Yeah, I mean, at first glance, it actually looked pretty cool, but our glow is completely gone. We don't have any red light being imparted to the wall on the right-hand side.
So it's like, oh, well, maybe if I just do something really small, what do we get?
You could almost think of this like a Gaussian blur that's applied to your final light map. Almost. I mean, not quite. But the same principle in that it's going to give you a smoother result at the cost of detail.
Right, and this is just a balancing act. You sit here, you'll do test renders, and you go, well, that's too much. It's like we've hit that threshold where it breaks. Now, we might not ever be able to find something that's acceptable, and that's all because our final gather rates are just too low. But it does prove the point, and the reason why I set these previews is so I can show you that these sliders do stuff. It's easier to see in this low res when we're smoothing stuff out when things are splotchy than if we had a really fine render and go, I didn't really see that.
All right, well, that brings us down to interpolation.
All right, so let's go ahead and bake this back out. Now this one's going to be hard to see regardless of even these preview renders. What interpolation does is it determines what type of calculation it's going to do between these final gather points to calculate the lighting on that surface between final gather points. So 0 is a linear interpolation, and 1 is an advanced, what's the word I'm looking for? Gradient.
Okay.
So it's looking for a smooth gradient blur between the points. Now it's not between point A and point B. That is determined by interpolation points. So this, by default, at its lowest setting, is interpolating between 15 of the points and doing a linear interpolation between those points to get the calculation at any pixel inside of our screen.
All right.
So if you've already seen what it looks like with interpolation of 0, if I crank this up to 1...
Now this should be a smooth result as opposed to a linear result.
Well, it's just smooth. It's using a gradient between it, but because our image is so low res, we're really not going to notice much. It's going to make things look like they shifted around a bit.
Okay.
So you really don't see it too much at this point. Where we start to see it, though.
Well, and when I say smooth, really what I'm referring to is a smooth gradient, where what you're really doing is controlling the rate at which you shift from one color to another.
Exactly. Now, if I take the interpolation points, though, and
kind of an
I
ease
adjust
in and
this,
ease out scenario.
So now it's using many, many more of these points across the board to calculate, and we get a much smoother result. And we can also switch back to linear and we can see what it does.
And that's a lot more like applying a blur to your final result.
Yes, it is. And that is pretty much the same problems that you're going to get with applying a blur. You're smoothing out your results.
Mm-hmm.
You're getting rid of a lot of the splotchiness, but you're sacrificing detail in your light map.
I mean, not to grossly oversimplify things or to pull it all into Photoshop land for just a minute, but I do a lot of work with Photoshop, so it all kind of it rings true for me anyway. The contrast threshold we played with a little earlier is kind of, in a really general sense, like applying a mask Gaussian blur to everything, where you lose a lot of detail, where interpolation points is kind of like applying a smart blur, where you're getting a blurred result, but it's trying its very best to hold on to a lot of that detail.
Right. If I were to turn off lights for a moment,
Mm-hmm.
you can see it's blurring out a lot, but it's being covered up
Right.
quite a bit by our lights.
Because the whole effect is softer now.
Right. So if I take this down back to 15, bake it out.
It's going to be a lot rougher. Ooh,
So
down to
not
almost
at
nothing.
all. Yep.
Yeah.
So, and we bring our lights back in. So,
Because we've basically turned everything off at this point.
so let's bake this out. Yeah, you can see our whole light map broke.
Yeah.
So, all right, now let's go ahead and get this back to where we need it to be.
Mm-hmm.
Because I turned off the lights and did a
Right.
bake.
Right.
It's like going,
I was just thinking, it's like you're baking with the lights off. That's going to make a really dark scene.
yeah. So if you bake the lights off, okay. So now I've got that. Let's turn the lights off.
Now we've shown how to bake with the lights off.
Yes.
Just in case
But-
you needed to know how to do that.
Now you can see we're using fewer interpolation points, and we've got much rougher changes in light.
Okay.
So that's what I want to show. And in case you want to know, don't bake with the lights off.
It's good that you demonstrated that, Lee.
Yeah, yeah.
Excellent work.
I meant to do that.
Of course you did. I know you did.
Matter of fact, but I only wanted to do it once. I'm going to turn
It's
the lights
right
back
here in
on.
your lesson
Okay,
plan.
very
I
good.
see it.
Yep.
All right.
All right. So we've covered everything all the way up to ambient occlusion now.
Mm-hmm.
Now, ambient occlusion is simply, adding shadows into the cracks.
Okay.
What it's doing is it's looking at our scene and looking for places where object surfaces meet another surface and determines whether or not there's going to be any occlusion between those two. Where it finds another surface meeting up, what it's going to do is try to darken that up, putting shadows in the cracks. Now, ambient occlusion at a setting of 0 is off.
Okay.
So you don't even see the other settings that are down here yet until you turn this on. This is a 0 to 1, so you can go from 0, no ambient occlusion, to 1, 100% of the calculated ambient occlusion is going to be applied in the scene.
Now, is ambient occlusion available in Pro?
Yes, it is, but it is also available into standard. Which
Okay.
I think is what
I
you were
think I
getting
meant
at.
to ask standard. Yeah, that's,
But yes, you
you
can
know
use,
what I meant.
But I know, that's why I was saying.
Right.
Yes, you can use ambient occlusion in standard.
Thank you.
Now, for sake of example, I'm going to leave ambient occlusion up to 1. Normally you don't want to do this, it's going to be kind of dark, but I'm going to do it for demonstration purposes. So if I bake out, you can see where we're starting to get some darkening along all of the cracks.
Mm-hmm.
This is probably too much. Ambient occlusion is a nice way to make objects look like they're sitting inside of the world.
Right.
But it's a subtle effect. You don't want to get too heavy-handed with it. Otherwise, it looks like somebody went in with a can of spray paint and painted all the corners.
Painted your corners down, yeah.
So the next one is max distance. This is going to determine how far out it looks for collisions between these surfaces.
Mm-hmm.
Now, this one you don't want to get carried away with. You can dial in some weird numbers.
And this should really darken things up, I think.
Oh, it'll darken the whole scene up.
Oh, okay.
So
Because we're going 5 units away.
yeah, so it's going to go, oh, well, hey, everything's
Oh,
within.
yeah.
So pretty much it's darkening up everything.
Gotcha.
So not exactly the result you want. Now, from a lot of playing around, 0.2 and everything that I've done up to this, your mileage may vary, is about as far out as you possibly want to reach. Now, like I was saying, this is kind of heavy-handed.
It is.
So what I would do is take this and dial it down to, about 0.4, 0.5.
Thereby softening the entire effect.
And getting it much more subtle. It's
Gotcha.
there, but it doesn't, hit you over the head.
Right, and it may be a little still kind of extreme there on that back corner, but I mean, it's just again a sake of playing with those settings for your individual level.
Right. Now, contrast is going to determine when something is going to be occluded and when it's not, and the drop off between the two. So this is a slider that goes between 0 and 1.
0 and 2.
Or sorry, 0 and 2, you're right. 0 and 2. So 0 being, everything is going to be occluded, which darkens up our whole scene again.
Gotcha.
Not quite as heavy-handed because we're dialed down to about 0.38. Or we can go to 2, and we're going to get a much more subtle effect. So you can use this to, in addition with max distance and your ambient occlusion number, to get the effect that you're looking for.
Literally brightening and lowering the contrast of your final ambient occlusion.
Right, and how far out from that crack is it going to darken?
Okay.
So, and that kind of brings it in. Still a little bit dark, but I think that's geometry. So, but in here and stuff, it's very, very subtle now.
Mm-hmm.
So that covers ambient occlusion, which brings us to our next setting, Lock Atlas.
Okay.
Now, Lock Atlas is kind of confusing if you don't know what's going on. By default, Lock Atlas is off, and for pretty much all instances, unless you're doing some crazy stuff with your light maps, you're just going to leave. All Lock Atlas does is when you check it, it disables the resolution, and it's going to use whatever resolution your light map had previously. But if you were to clear this and then bake out your light maps again, it's going to build out 1K maps. So that's just something we found through testing. What it does do, though, is if I select an object inside my scene, like this red ball, and I expand out this atlas here, it's going to prevent these numbers from being changed the next time I bake out maps. Because what the light mapping tool is going to try to do is it's going to look at every object in your scene that is marked as static, and it's going to calculate a UV layout for it and position it inside of the maps. And it will break it up over multiple maps if it needs to. What Lock Atlas is going to do is it's going to prevent these numbers from being changed. It's not going to recalculate these the next time you bake.
Okay.
Now, this is the part you have to be aware of, and this is kind of something that most of us find by accident for the very first time. Both Bake Selected and Bake are going to delete any light maps that you have in your scene if they're in the default location. The default location is going to be in a folder with the same file name as your scene.
Okay.
So it's going to, wherever you've saved your scene, at that location is going to create another folder with that name, and it's going to put all the light maps in it.
Gotcha.
Anytime you hit Bake Selected or Bake, these are going to be overwritten or deleted. Now, where this comes in handy, or where it bites most people, I should say, it doesn't come in handy at all, is let's say you baked out and you add a new object. Let's say we baked out and we just added this new red ball in here. We go, oh, well, I've already got all the maps for everything else, so I've got that ball selected. I just want to bake that.
Right.
I hit Bake Selected. Give it a second. It just wiped out everything but that ball.
Gotcha.
So where this will, make you want to throw your computer out the window is, after that day you spent 12 hours baking out, reading that really good book, coming back and realizing you wanted to add one more thing, and then you bake just that thing, and those 12 hours of light maps go bye-bye.
So a good idea, if nothing else, to make sure that you back up your light maps.
Yes. Now, this is where you lose the automation. If you've spent a lot of time baking out all these light maps by hand, that's where you want to use Lock Atlas. You want to lock this atlas. You want to take these light maps, move them out of the default location, put them somewhere else in your scene in a folder that you create.
Okay.
That way, when you go and you hit either Bake or Bake Selected, you're not going to lose those maps. Unfortunately, it will throw everything away inside of this map folder, and you're going to have to hand drag everything back, and you're going to have to make sure that the maps show up in the same atlas where they're at so your object can find them again. With one map, not a big deal. 10 maps, annoying. 254 maps times 2, very annoying.
Right.
So, again, it's one of those limitations on just the way the light mapping engine works. Nothing you can really do about it unless you really want to get into scripting.
Though it seems like if you did add a new object to the scene, you'd need your whole light maps to be recalculated anyway, because it's going to have to possibly move all of your other objects around on the map to get them positioned properly.
Right, but if you think about it, let's say this red ball is inside of this room, and the only thing that really needs to be calculated is inside of this room, and I just select all the objects in that room. But outside of this room, I have an entire game level.
Right.
And I don't need to rebake all those light maps too. I just need the stuff inside this room. It would have been really handy if we had a way of doing that.
Sure.
We don't. So that's just something that you have to be aware of, be careful of. Otherwise, it's going to lead to a lot of frustration.
Okay.
So, and we've already covered what resolution does. Again, it's just basically determining how many pixels per world unit are going to be allocated on the light map for your objects.
Okay.
So, with that, that's everything inside of our bake panel. So, I'm going to just go ahead and do one last bake of everything so we can get something other than that, so we can finish with that. But that is everything inside of the bake panel that I wanted to cover in this video. In the next video, we're going to finish up with our maps tab.
Sounds good. Thank you very much for watching.